Lecture, we will see about the regression and transformations of two-dimensional random variables. So, regression is a mathematical measure of the average relationship between two or more variables in terms of the original limits of the data. Here, this is the formula for lines of regression. It is divided into two types. The line of regression y known as given here. Y minus y bar is equal to r into sigma y by sigma x into x minus x bar. Here, x bar and y bar are the average values and what is the correlation coefficient, and sigma is the standard deviation with respect to x and y. And the second type is the line of regression of x on y, which is given here. That is equal to x minus x bar equal to r into sigma x by sigma y into y minus y bar. The line equation starts from x means the LHS starts from y. So likewise, you will do it. Okay. So next we will say about the regression coefficient of y on x is. The notation is bys. Y on x means b suffix ys, which is equal to r into sigma y plus sigma x. And what about regression coefficient of x on y? Its notation is bxy, that is equal to r into sigma x by sigma y. Next we will calculate the angle between the regression line. That formula is m1, that is equal to that this part r into sigma y by sigma x. Then what is for m2? That is 1 by r, either it is not 1 by r. Next, if theta is the angle between the regression lines, then tan theta is equal to sigma x into sigma y divided by sigma x square plus sigma y square into 1 minus r square divided by r. Here sigma is the standard deviation and r is the correlation coefficient. In the first problem, we have to find the two regression equations, that is x minus x bar, that line equation, and y minus y bar, that equation. Next, we will find the coefficient of correlation between the marks in the economics and the statistics. Next, we will calculate the most likely marks in statistics when mark in economics are 30. So, some data is given. First row represents the marks in economics, and second row represents the marks in statistics. Now, we will going to see about the solution. We want x minus x bar term in LHS, right? Now we will calculate x minus x bar. X bar is 32 means the average value. The average value is 32. So we have to subtract the x minus the data in all the x values. It means likewise for y minus y bar, we have to find. Next, we will calculate x minus x bar the whole square. This is x minus x bar value. So we have to square these values. Actually, we have to find y minus y bar the whole square values, and finally we have to multiply this two columns. Next, what is x1? That is summation xyn. That is 32. And y1 means summation y9. Next, we have to calculate the coefficient of regression. That is vyx. Another formula is summation x minus x bar into y minus y bar whole divided by summation x minus x bar the whole square. So we already know these values. Substitute here, we get the final answer. Regression coefficient is vyx and vyxy. Regression coefficient. So xy formula is the numerator is same. What is the denominator? We have to divide it the summation value of minus y bar by whole square. Next, we want the line equation, right? So the formula is x minus x bar equal to b x y into y minus y bar. Substitute the equation. Finally, we get the line equation in terms of x and y. Likewise, we will find the line equation for y on x. So that is given here. It is in the form of y and x. Next, we have to find the correlation coefficient R. Generally, R square that is equal to the multiplications of the correlation regression coefficient of x on y and y. So already we know this formula and the values. We have to substitute r square equal to 0.1552. But we need the correlation coefficient smaller. So we have to take square root on both sides. We will get the plus or minus 0.394 plus the r value. Now we have to find the most likely mark in statistics. This is the third question. So here, why we have to find, we want some economics x is given. We have to choose that we the line regression line equation of y on x. That equation we have taken. This is that equation. We substitute in terms of x equal to 30. We get the value. This is the tutorial problem. X and y values are given. We have to obtain the equation of the lines of regression. So line of regression of y on x is given here and x on y is given here. Substitute all the new values, we get the line equations of x and y. In the next problem, the function is given here. We have to find the regression of y on x. Okay. So another formula is expected value of y given x, which is we already know that the limits are given y into f of y by x into y. Then what about for f of y given x? This is the conditional probability, which is equal to f of x comma y divided by fx of x. So here, before calculating this, we have to find the fx of x. This is equal to minus infinity to infinity f of x comma y into dy. This is our initial value. Substitute here and integrate that. We get the final value of fx of x. After that, we have to substitute in this conditional probability value. We get f of y given x, which is equal to x plus y divided by 2 into x plus 1. Finally, the regression equation of y on x is expected value of y given x. This is the formula. We have to integrate this. Finally, we get the regression equation of y and x. This is the problem. Here, the two regression lines equation is given. We have to find the mean value of x and y, that is x bar and y bar, and the correlation coefficient. What we have to do, we have to replace x and y as x bar and y bar. And solving these two equations, we get the average mean values. Next, we have to find the line equation. So one equation is given, we have to replace it in terms of y on x. So in that, byx means this coefficient 8 by 10. Likewise, we have to modify the second equation in terms of x and y. And the coefficient of y is bxy. So finally, we have to calculate the correlation coefficient, that is equal to square root of byx and bxy. In next two concepts, we will go to two functions of two random variables. So here, some theorem is given. If x comma y is a two-dimensional random variable with a joint probability density function, and if some z function transformation is given, and y function, w function is also given, or two other random variables, then the joint probability density function of z comma w is given by. We are taking z comma w to so joint density function means it is a continuous random variable. So relation f of zw of z comma w equal to modulus of j into f of x comma y x of x comma y, where this j is the determinant value of x and y variables with respect to z and w. There is a Jacobian value. So in the first problem, we have to find the density function of x plus y divided by 2, we have to find it. So here, the continuous random variable function is given, that is probability density function is given here. In this, we have to pick new values equal to this x plus y by 2. Next, we have to define a new variable, v is equal to, we have to define a new, so we have to take it as x. So substitute this value in the first equation. In the second equation, we get the values for x and y in terms of u and v. Next, we have to substitute in the transformation equation g of u comma v is equal to f of x comma y into j. J means Jacobian value, right? So Jacobian value is the coefficient we have to take. So here we have to calculate the Jacobian value. These are the coefficient values of this derivatives, and finally we get the determinant value as -2. So substitute this value in this equation. This function is given previously in our question. So substitute it. And finally we get the format in terms of u and v. Next we have to find the range, right? Because it is a continuous random variable. So we have to find the range. It is already given that x greater than 0, y greater than 0. So I have to take x greater than 0, y greater than 0. We have taken new variable v equal to x, right? So we have to replace it here. So v is also greater than 0. Next, in terms of y, we have found that 2u minus 2. This is also greater than 0. Solving this, finally we get 2u greater than v. This is also equal to, we have to replace it as v less than 2u. Both the notations are same. Finally, we found the v range that lies between 0 and 2u. So we have to find the probability density function of u. Why here we have taken u? Because in the previous step, we have assumed u equal to x plus y by 2. They are asking The question is about probability density function of x plus y by 2. This is also, we have to take it as probability density function u. So we have finally we find the probability density function of u, that is g of u is equal to minus infinity to infinity g of u comma v into dv. G means we have already found in the previous step, that is Jacobian into the given function. Then we have to substitute here. The range of v lies between 0 and 2u. So we will replace this limits also, and finally we have to integrate this function with respect to v. Here 2 into e power minus 2e, it is a constant function. We have to take in this outside the integration, and only we have to integrate dv. So the integration of dv is a v. After that we have to substitute upper limit minus lower limit. That is 2u minus 0 is 2u. So this is the final answer, and here also u always greater than 0. This is the tutorial problem. Here, the two-dimensional random variable we are taking, and it is a joint probability density function. So it is a continuous random variable. That function is given here. Note that x and y both are greater than or equal to 0. What we have to find? We have to find the probability density function of u is equal to x minus y by 2. In the previous question, it is about probability density function of x plus y by 2. X minus y by 2. Same process, just to change the u value and calculate the joint probability density function. So this is the final answer. Check it. Thank you.